section 4.3, the complement and conditional probability. So let's go over the complement first, right? And then we go to conditional probability later. Let's go to the definition of it. So if you have an A be an event of getting at least one of some event, complement is going to be getting none of the event being considered. So if you look at the Venn diagram, if your event A is the circle here, complement of A will be everything else outside of A. Again, to calculate this, probability of A is equal to 1 minus probability of complement of A. So let's look at the first example. Find the probability that when a couple have 5 children, at least one of them is a boy. At least one of them is a boy. So let A be the event that all 5 children are girl. If A is all 5 children are girl, the complement will be at least one of the 5 children is a boy. Alright, that's the, think of A is the event here and complement of A is the not A or outside of A. So if you're going to do the tree diagram, if you have the first child, you're going to have 2 possible outcomes. Second child, you're going to have 4, BB, BG, GB, GG. Similar to the previous lecture that I gave it to you. The third one, you're going to have 8 possible outcomes. The fourth one will be 16 and the fifth one will be 32 possible outcomes. So total possible outcome will be 2 because there are 2 possible outcomes, boy and girl, to the fifth because you have 5 children. So it's 32. So probability of at least one of 5 children is a boy will be 1 minus probability of all 5 children a girl, which is 31 over 32. Okay? So let's look at the next example. When 4 digits 0 to 9, including 0 and 9, are randomly selected with replacement. With replacement means if you pick some number, that number can be picked again. For a lottery ticket, find probability that at least one of them, of the digits is 0. So at least one. So let A be the event that none of the digit is 0. So none of them is 0. So you have option from 0 to 9, you take out the 0. So you have 9 out of 10 left. And it's 4 digits. So 1, 2, 3, 4. So 9 over 10 to the 4th, which is 65.6%. Now, they want to find the probability that at least one of the digits is 0. One of them is 0 will be 1 minus none of them is 0, which is 34.4%. The next one, probability of the calculator will work on any given day is 92%. So not work on any given day would be 8%. Now if you have 2 calculators, you want to find probability of at least one of the 2 calculators that work. At least one, mean one can work or 2 can work. So if both of them work, it's going to be 0.92 times 0.92. That's one possible. Or the first one works, the second one doesn't work, or the first one doesn't work, the second one works. If you multiply this and this and this and add it together, it's going to be 99.36%. Which means if you bring 2 calculators to take the test, 99.36% that at least one of them will work and you can complete your test. If you only have one, how many percent is that? One will be 92%. So 92% will work. Alright, so let's look at the conditional probability. And let's look at the conditional probability. Okay, the first example, a balanced dime is tossed twice. List all the possible outcomes. So this is how you list the possible outcome. The first time you toss, you have 2 outcomes, head or tail. Regardless of what happened to the first time you toss, if you have head first, you're still going to have head or tail. If you have tail first, you're still going to have head or tail. So you can have two head, head and then tail, tail and then head, and both tail. So that's 4 possible outcomes. So this is called the tree diagram. Let's look at the first question. Find the probability that the second thought is heads, giving that at least one thought is head. So this is a giving condition. That's why it's called conditional probability. So what you do, you look at the condition first. All right. Given, this is the condition. Given at least one thought is head. So go back here. At least one thought is head is HH, HT, and TH. This is the given. At least one thought is head. And out of this, find the probability second thought is head. Second thought is head. This is the first thought. This is the second thought. So this one, this is the first thought. This is the second thought. So this one doesn't work because the second thought is tail. And this one works. First thought is tail. Second thought is head. So probability second thought is head. So it's going to be 2 out of 3, which is 0.66 bar or 66.67%. Right? And the way you write this, let's say I call that the second thought is head A. So you're gonna write probability of A given B. So it's a given condition. So you list the given, and out of the given, how many of that event happened. Now let's look at this one. Find the probability that second thought is head. Now the given is different from the first one. The given is that the first thought is head. So the first thought is head is this one, the first thought, that's it. This is the first thought is tail, the first thought is tail. So you're gonna have HH and HT. This is the given. The given, the first thought is head. What is the probability that the second thought is also head? So this, the second thought is head. So it's going to be 1 out of 2 or 50%. Alright, same question, but the given is different. Now let's look at this example. You have two groups of students. One group, you give them 4 quarters. 4 quarters is still $1. And then another group, you give them $1 bill. And then the one that you give 4 quarter, 27 of them purchase gum, 16 of them keep the money. And all of them is 43. The one that you give a $1 bill, 12 of them purchase gum, 34 of them keep the money. So all of them altogether is 46. The question is, find the probability of randomly select a student who spend money given. This is a given condition, it's conditional probability. Given that the student were giving a quarter. This is the one that we give a quarter. Given this, 43. Given 43. Okay, given the student were given 4 quarters. This one. Find the probability of randomly select a student who spend the money. So 27 of them spend. 27. So that is turned out to be 0.628 or 62.8%. Now look at the second one. Find the probability of randomly select a student who spend money, both spend money, but the condition is given that the student, I spelled student wrong, but student were giving $1 bills. So all of this is the people that we give $1 bills. So it's out of 46. And we want to know the one that spend the money, so it's 12 of them, 12 out of 46. Which is 26.1%. So it seemed like if you give them $1, the one that have the bill, 26%, 26.1 of them, 26.1 of them spend money. But if you give them a quarter, 62.8 of them spend the money. Alright, we finished 44.3. See you next time.